AI agents will be the big topic in 2025. The concept of agents will make a lot of the promises of large language models actually come true. If you have not been living under a rock for the last few months, you've probably also been bombarded with news like this. Y Combinator saying that AI agents could be 10 times bigger than SaaS, or Jens Nguyen from NVIDIA saying IT will become the HR of AI agents, or Zuckerberg saying they will not hire new mid-level engineers because they will automate all of that with AI agents. So the hype is definitely real. Everyone's talking about it. Everyone thinks it's the next big thing. But what on earth is it actually? What actually are AI agents? It turns out no one really knows. It's a pretty new concept and everyone's got kind of different ideas about it. I like a very simple definition. For me, it's an AI agent when a large language model can actually do something. And that can be a lot of different things. It could, for example, be a web search. The large language model might come up with the idea that it has to do a web search to answer whatever it's supposed to do. Or it could also create its own Python code and execute it. Or it could retrieve or even change data in your HR system. The options are endless. Anything you can do on a computer can be something that can be a tool for an AI agent. Well, and that's it. That's the main idea. When you have a large language model that can decide to do something and then actually do it, you have an AI agent. You don't have to stop there. You can have multiple agents that communicate like a team or like a crew, shout out to Crew AI, that actually work together to solve something. But that is out of scope for this video. What I want to do here is demystify AI agents and show you how they really work, because it is surprisingly simple. So first things first, I want to remind you of something. Large language models are text in, text out. I know they can do images, but that's not important here. You need something that does the actual interaction with like the real world, that does the actual web search, the request to Google, the request to DuckDuckGo, or that can do the SQL query to your HR system. So we need something that constantly listens to what the large language model puts out. And if it, for example, says to answer this question about NVIDIA, I need to do a Google search about NVIDIA. Our system has to actually do that Google search and return the results and also put them in the prompt so the model can use it. You can build those systems yourself in theory. It's not that hard. In practice, don't. Well, just don't. It's a bad idea. Don't build them yourself. Use what is already out there. There's a wide selection of different frameworks that you can use for that. For example, LangChain or Crew AI or B, which is what we will be using in this video. They are all great options. So that's the one aspect. We need to give the large language model a way to interact with the world, which is going to be our framework and the tools that we define within this framework. But we also need to tell the large language model what we actually want it to do. And that is where a concept called ReAct comes into play. You hear about ReAct pretty often when people want to seem knowledgeable about the whole AI agents trend, but very few people can actually explain to you what it is. If you Google ReAct, you end up with the JavaScript library, and that is not the same thing. Very important. This is completely different thing than the ReAct framework that we're talking about. ReAct in the context of AI agents stands for reasoning and acting, and it is based on a paper published in 2022, and to this day it's pretty much the basis of how you make large language models behave like agents. I personally had kind of a hard time understanding that paper, to be honest. Ever since 2022 I had like probably 5 attempts of actually understanding the concept. And it's super simple once you see it actually being used. And that's what we're going to do now. If you enjoy this content and you want to enable me to do more of this, it really helps if you subscribe to the channel or leave a like. Thanks. For that, we jump into the IBM watsonx platform and go straight to the Prompt Lab, which is pretty much a IDE, an integrated development environment for prompt engineering. We're going to choose a pretty small model, one of the Granite 3 8 billion parameter models. I came up with a very simple question that gets large language models confused quite often. What was the movie that Tom Hanks got his second Oscar for? And this second here is like with humans as well. You hear Tom Hanks, Oscar, like, yeah, right, that is, by the way, the answers are here. That is Philadelphia, but well, it turns out the second Oscar was for Forrest Gump. I wrapped that question up in a very simple user and assistant dialogue. So that's pretty much the most naive way you can ask a large language model anything. So if I hit generate, it tells me about the movie Philadelphia, and that's kind of a common thing in large language models. Actually, that's the way they work. They come up with something, and everything that comes after that is just a way to explain the first thing they come up with. I mean, at the end of the day, they're just next token predictors. So as soon as they said something, anything that's going to come afterwards is just going to reinforce that. A very powerful idea to work against that is called chain of thought prompting. It's been around for quite some time, and it's a very fancy term for just typing, let's think step by step at the end of what you're trying to achieve. So this makes it chain of thought prompting. Let's hit generate. There we go. Tom Hanks has won 2 Academy Awards. First Oscar, Philadelphia. Second Oscar, Forrest Gump. So the movie Tom Hanks got his second Oscar for was Forrest Gump. Final answer, Forrest Gump. So what we did here is kind of manipulate the way this large language model thinks. And we were kind of pushing it to reason first before giving an answer. So why am I showing you this? I mean, this is chain of thought prompting. This is not ReAct. It's kind of the same idea. We're forcing the model or manipulating the model to come to a conclusion in the way we want it to come to that conclusion. And that's the same idea in ReAct, but a lot more sophisticated. What I have here is the original prompt from the ReAct paper. We can already see we don't have any sort of instructions or anything. We just have 1, 2, 3, 4, 5 examples. And down here, I already copy pasted our question. So all of those examples have the same structure. They all start with a question, and then they have a repeating sequence about thought, action, and observation. Thought, action, observation. Let's go through this example, because it's the most relatable to me as an old Simpsons fan. It's about the character Milhouse, who Matt Groening named after who? So that's the question. And in the thought, the model reflects what it already knows and what has to happen now for it to answer that question. And it comes to the conclusion that it needs to do a search for Milhouse. This would be a web search. And this search results in the observation, which then results in another thought. And it comes to the conclusion that it needs to do another search or a lookup. Actually, in the ReAct paper, this is all Wikipedia. Usually you would rather do like a Google or DuckDuckGo search. Anyway, this action resulted in another observation, in another thought, and then another action. And that action is the finish action, which is the keyword for the model to tell us that it's done, and it came up with the final answer, which is Richard Nixon, which is kind of a surprising fact, to be honest. Well, so that's the structure of a ReAct interaction. Those 5 examples tell the model what we expect it to do. And now we can click generate to see what it does with our question. So it did follow the structure that we defined in the examples. It came up with a thought, an action, observation, thought, action. That looks good. The thought is, I need to search Tom Hanks and his Oscar wins, then find the movie he got his second Oscar for. That is a very good thought. And then it comes up with a action and search for Tom Hanks Oscar wins. And that is a great idea. But obviously this search at this point did not happen. Because, I mean, how should it? Like, this is a prompt. This is what's an X-Prompt Lab. This is not connected to Google or DuckDuckGo or anything. Like this, the result of this search is completely hallucinated. And this is exactly where the framework would come into play and say, let me stop you right here. Like, great, but stop for a moment. It then takes this search, Tom Hanks Oscar wins, and translate it into an actual Google search and execute this and take what comes back from Google in this case and summarize this and then copy paste this observation in here and let the large language model continue from there. So to summarize this, the ReAct way of prompting only makes sense when it's done within some sort of a framework that actually executes those actions. And this back and forth between the underlying large language model and the framework that executes the tasks that the large language models wants it to do, that is what makes an AI agent so powerful. I have added a few things here at the top to make it look more like it was actually generated by a modern framework like LangGraph or B framework, because usually you want to give it more tools than are here in the original paper, and it then looks something like that. First, you have somewhat of an instruction, your intelligent assistant designed to gather and process information. And then, very important, you describe the collection of tools that are available in this framework. So everything here has to be actually implemented in LangGraph or in B framework or whatever you're using. And then it is added to the prompt to tell the model that it can actually use those tools. Those tools always have a name, for example, web search, and then they also have a description, which is very important because that's what the model uses to decide if it actually wants to use that tool. So those tool descriptions, they are a form of prompt engineering in itself. So those descriptions are very important. It's very important to actually phrase them really well. And then there's always an example on how you actually call that tool. Calling a tool pretty much means that this is what the framework is looking for. And as soon as it finds this phrase within the output of the large language model, it's going to execute this actual web search, the actual code that has been defined when someone implemented this web search tool. I hope this whole introduction helps you understand the second part of the video. I'm going to actually show you this principle in a real-world application and the way it is implemented in a modern framework. Enough theory, let's get real. Let's look at some options how you can build systems like that today. As I mentioned, there are a lot of really good frameworks. For example, LangGraph or ReAct, or what we will be using here, B framework. They all have their strengths and weaknesses, but the B agent framework is pretty awesome because it has a really high focus on observability, which is super critical. And it's also written in TypeScript and it can use the full TypeScript stack. This is pretty unconventional these days because pretty much all of AI and Gen AI is Python. And while Python is awesome and really easy to use and probably also easier to use for agent systems, the real world, the applications that you actually interact with, like the apps on your phone, the websites that you interact with, they are not written in Python. They are mainly JavaScript/TypeScript based systems. Sure, we live in the world of microservices and containers, so you can pretty much make everything talk to everything. You don't need to stick in one programming language. Still, in a real world production application, it can have real benefits if you can stay within the same language / within the same stack. Anyway, those considerations are beyond the scope of this video. You'll be using B framework because it's easy to use and it's pretty easy to look under the hood. So let's go. When you first check out the repo, or rather the project, you can find a lot of different repos with the B agent framework, which we're going to open right now, being the main repo with 1,500 stars. But please consider, while this is really awesome, we are still in a pretty early stage here. So here you can find the source code and a lot of documentation. But what I would recommend to get started is to use the B agent framework starter. You pretty much just clone that repo and then run an npm CI, which is going to guide you through the process of creating an environment file, which is going to require you to provide some sort of an API key for the large language model provider that you want to use. We'll be using watsonx here. So I got my watsonx API key and a project ID. If you've got questions about that, just shoot me a message. I can show you how it works. Oh, here we are in my IDE, and we will do exactly what the README tells us to do and run npm run start source agent.typescript. And that's going to start our first pre-configured agent. That agent is a very simple use case. It just asks about the weather in Las Vegas, which is kind of a hello world kind of example. And you see it thinks about what it needs to do. And then it comes up with the fact that it's got a tool called OpenMeteor, which is like an open API for weather data. Then it calls that tool and it gets a response back, and then it thinks about that response, and then it comes to the conclusion that it does have all the information that it needs. Then, because this is the keyword for the final answer, the framework gives us back this answer here. If you look at the source code, we can see how this agent is built, and it's actually pretty simple. You pretty much only define three things. In this case, the large language model. Which model to use is defined in the .env file. In this case, we just use llama 3.170b, which is probably overkill, but well, it's fine for a demo. Your API key, project ID. Remember to keep your API key secret. And then you gotta define the memory, which is irrelevant for what we're doing here. But if you would keep that service running and have an actual chatbot kind of interaction, this would mean that it would, well, remember what you already talked about, which does affect the behavior a lot. So memory, that's a whole chapter within itself, but here we just use token memory. The exciting part for us here are the tools. We're going to provide it with the OpenMeteor tool and the Wikipedia tool. If we want, we can also check the source code of the B-agent framework and look at the OpenMeteor tool, which is like this whole code here, and particularly this part, the description. That's what I said, that part is super important, because that's what the model will actually know about this tool, and that's what it will use to decide whether it wants to use that tool or not. And everything else here, I mean, those are a few hundred lines of code. This is the actual interaction with that API. Like that actually sends the requests, gets the answer, passes the answer, all this good old code stuff that needs to happen to actually do a request. We can also pretty easily add our own tools, but again, out of the scope for this video. And then we have a pretty simple setup that's just used for Hello World showcase purposes. In a real world application, you would keep that service running and have a constant interaction with the user. Right here, it just simply has a predefined prompt, just so it's really easy to get started. And down here, you have service and emitters that you can use to tell the framework what it should print out to you on the console. And to explain to you now how this connects to the theory that we've done in the first part of the video, I created another agent where I just changed this observe block and I added a lot more emitters to create somewhat of a debug mode. Let's run that. Let me clear this here. And now we just run that agent that I called debug. And it does the same thing. It just prints out a lot more information to us. So it probably gets to the same answer at the end. You can see that's kind of a lot of output. Final answer is the same, but let's start from the top here. See if we can find something that we recognize. Oh, that part looks pretty familiar. This is all happening before the first interaction. So let's take this whole thing that's kind of hard to read and make it a bit easier to read. So I just copy paste this whole part. Then I jump over to the prompt lab just for convenience and ask, can you make this easier to read? Paste this in there. A lot better. It starts here, like the chapters are kind of in a weird order. I don't know why, but it's the very same things that we've seen in the first part of the video. It explains the available functions here. We find here again the description that we've already seen in the source code. Here it explains in quite a lot of detail how this tool has to be used. So that's pretty much all the parameters that are needed to actually get an answer from that OpenMeteor API. Large language models are surprisingly good at handling those kind of JSON objects. They are kind of unfriendly to us humans to read, but it works surprisingly well that a model is actually capable of reproducing a structure like that and fill in its own parameters that it came up with within the conversation. And that way it's got all the tools described here in this prompt. The Wikipedia tool is the same thing. It's a lot easier to use, obviously. And here it describes the communication structure, which is pretty similar to the original ReAct paper. Kind of different though. In the original paper, it always was thought, action, observation. They kind of changed it here and thought, and then they describe how to call the function, like function name, function input, function output, and then a thought, and then the final answer. It's different, but it's the very same idea. And then they also have one example, which is a super simple example. That's the point where you could tailor it to your use case, where you would have the most leverage to tailor it to your use case and actually provide examples here that even use the tools that you provide. And here at the end, it also got some instructions which are really interesting. The user can only see the final answer all answers must be provided there. And also here at the end, when the message is unclear or you need more information from the user, ask in the final answer. Here it's also got described what its own capabilities are, so the capabilities of the base language model. So obviously if you've got use cases in German or any other language that is not English, Spanish or French, it might make sense to tailor this prompt here. So what I'm trying to show you here is that this prompt that is the basis of the whole interaction is very, very similar to that prompt that was proposed in the ReAct paper almost 3 years ago. So if we scroll further down here, we can follow the exact interaction. Thought: to answer the user's questions, I need to read the current weather forecast. It recalls the name of the tool that it wants to use, creating the input that it needs to do the actual API call. I always find it surprising to see that large language models can pretty easily create JSON structures like that. I mean, that's still pretty simple. A model like that can create really, really complex structures really reliably. And that capability is what you call function calling. Like, it's kind of there are separate metrics for that because it's a really important ability of modern models. So if we scroll further, we can see somewhat of a summary created by the B framework. Then we see the actual output of the tool. So this actually came from the internets, from OpenMeteor, and that tool output concludes one iteration. And now what we can see here, which is kind of a, I guess, sad truth about agents, it has to start the whole interaction again and append this to the end of this interaction so that the model can continue to reason, including the information that it got from that tool. So we can see that really clearly here. We start all over here again. Like, you can only use the following functions. This is the very start of the system prompt. This is the whole thing again. And here it goes on, 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 and it goes on until here. That's the part where the first iteration stopped. And now we are in the second iteration where it's actually thinking about what the tool has put out. And well, the function output contains the current weather forecast for Las Vegas. And so the model comes up with the keyword final answer, the current weather in Las Vegas. And this is what is printed here at the end, the current weather. So what you can see here in this very simple example is that agentic systems, they chew through a lot of tokens. So when people keep talking about the importance of small large language models, that's a pretty big part of the reason why this is important now and will be even more important in the future. So when you have pretty complicated agentic interactions, there are thousands or hundreds of thousands more tokens being consumed than what you actually see. You can also easily create your own agents that are far more specialized. For example, I created a IT help desk support agent that got access to different tools, for example, DuckDuckGo search, and the prompt is completely different. But that is out of scope for this video. I will make other videos about that in the future because there's other stuff I want to show you. I want to show you the B stack, which includes the B UI, which is a glimpse into a future that, well, kind of already exists. This is running locally here. You can see there. It's super easy to set up. You just clone this repo and then you run bstack start. It's going to pull some images, do a Docker compose, and you're ready to go. So this is a UI for building your own agents, and it's super simple. You start by clicking a plus on a new agent. There are a few templates, but we will just simply start from scratch, and we will be creating a travel assistant. This is the description for the user. It's not that important. This is a B-based travel assistant. Doesn't matter, it's just what is going to be the greeting here. The important part is what you put into this role. This is the actual prompt that defines the agent. You can just very naively go ahead and write your own prompt here. I already did a little bit of prompt engineering and did some back and forth with Llama 7db within What's Next, and I came up with a prompt like that. Nothing spectacular. The other thing that is critically important for an agent are the tools that you provide. Per default, it's already got a Python, a read files, and a file search tool. We don't need them for what we're doing, so we're gonna disable them, but we are going to add a few tools, and that is DuckDuckGo for web search, Wikipedia and OpenMeteor for weather data. Let's add those 3. And just like with any piece of software, you want to keep your agents dedicated to a purpose that's as specific as possible. You might be tempted to create the all and everything agent, which can work, but you're doing yourself a favor if you cut them as small and as deliberately as you can, because that will make your life a lot easier when managing a bunch of them. Now we can already start with a question. We are a family of 4 with a toddler and a 3-year-old. We are from Germany. We want to avoid school holidays. We want to do a 2-week vacation in early summer. Our budget is about 3K. Let's go. So it's starting with a thought. User wants to do a 2-week vacation in early summer. Okay. Now it asks me if it's allowed to use DuckDuckGo, of course. Okay, it found out that based on the search results, some European countries have different school holiday schedules than Germany. Well. Okay, now it asks me if it's allowed to use Wikipedia. Sure. So it was not able to retrieve the summer holidays in France in 2025 from Wikipedia. Now it's trying to search it on DuckDuckGo. That makes sense. Okay, now it's asking me if it is allowed to use OpenMeteor. Sure. Okay, it's searching for... Oh, okay, it closed it. It was searching for August, but OpenMeteor does not... only allows like a few weeks in advance. Okay, so it kind of ditched that thought. And the final answer now is, based on my research, I recommend considering France as a potential destination. Blah, 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 blah. Okay, it comes up with a bit of an explanation here. Well, that is a very reasonable answer. You might be asking yourself now, why should I go through all the trouble when I can just Google that or ask ChatGPT? And you are absolutely right about that. We are talking about AI for enterprise here. If you have consumer-grade problems, you can use the consumer-grade tools. They are better, they are free, they are no hassle. Don't worry about that. But this becomes awesome when you give it access to your internal documents and your internal tools and your internal systems in general. This can do so many things that pretty high-paid people are doing at this moment. The key for that are the tools, and it's super easy to create new tools here. You can create them in TypeScript, you can create them right here in this custom tool editor. It's super simple, and it will provide you with the very same traceability as you've seen here. I hope this video gave you an idea about what agents are, how they actually work under the hood, and what is already possible. It's important to keep in mind that we as consumers are kind of spoiled. We all have access to some really amazing tools by now that are amazing at general purpose agentic tasks. But when it comes to enterprise use, to AI for enterprise, the rules are different. What counts there is traceability, transparency, reliability in general. And this is where we see a lot of advancements being made. 2025 will be a wild ride. So I hope you're looking forward to it as much as I do. And if you've got any questions or want to chat about anything that I've shown here, just shoot me a message on LinkedIn or YouTube or just comment under this video. Thanks. Bye.